Welcome to solverfy.
All right, so problem number 12, it wants you to estimate how much energy is given to a proton every time it goes around the Fermilab Tevatron. So the problem states that it takes 20 seconds, so delta T is equal to 20 seconds to bring 20 seconds to bring up the energies of the protons, the stored protons, from 150 gigaelectron volts to 1 teraelectron volt. So it's accelerating it from 1 TeV minus 100, say 0.150 TeV. So that it changes energy of approximately 850 gigaelectron volts. So since we can assume, it states in the problem that we can assume that the speed of the proton is essentially c the whole time, we can state that the period, the time it takes to go around one revolution, is equal to 2 pi r over c. But now we need to know how much energy is gained per time per revolution. So we need to know how many revolutions the particle takes in the 20 seconds that we have here. So we can say that the total number of revolutions is equal to the total time that it's traveling divided by the period, the time it takes. So now the energy gained per revolution can be given by delta E, so how much energy, the change in energy, divided by the number of revolutions. So the total change in energy divided by how many times it's been accelerated to gain that energy. If we make the assumption that every time it goes around, it gains an equal amount of energy, which we do for this problem. So we can now plug everything in. So N is equal to T over the total time over the period. Let's go ahead and plug in what we know for the period. So this is equal to the total time times the speed of light over 2 pi r. So now we can plug that value in here for N and say this is equal to delta E times 2 pi r over CT. Now if we plug in all of these values, let's see, it's coming down here, delta E over N is equal to so the energy gained, let's see here, no, that was correct. Sorry, I was saying I should probably rename this for something else, but no, it's the energy gained per revolution is just going to be equal to the total energy gained, which is 1.00 times 10 to the 12th electron volts minus 0.15 times 10 to the 12th electron volts times 2 pi times 1.0 times 10 to the 3rd meters, so the radius of the ring, divided by the speed of light, 3.00 times 10 to the 8th meters per second, times the total time that it takes to build up that energy, 20 seconds. So real quick, I just want to do some unit analysis here. So the seconds here cancel, the meters here cancel. So that's going to leave EV times 2 pi per revolution. So it's 2 pi for a full revolution. So your units are going to be EV per revolution, so it's going to be the correct units. We could convert this to joules and say it's going to be joules per revolution, but it's not necessary. So if we work through this, we end up with 0.89 times 10 to the 6th electron volts per revolution, or 0.89 MeV per revolution.